Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today I have Hantek in the lab and I want to show you this little handheld scope. It's a 70 megahertz scope, 2-channel. They actually call it a multifunction meter because it has a multimeter function and it also has a generator function. So we want to check those things out. Now the multimeter, I see that it's a 4,000 count. So I usually kind of consider 4,000 count meter around a $40 meter. So it's got like a $40 meter built into it. We'll see how good that is, okay? But yeah, let's check it out. I've had viewers ask me about these little handheld scopes, so I just want to check. I want to take a look at one, and I think of the ones I see in the price range, this looked like a good option. Also, I signed up with Banggood, so I have a link below. I believe I'm going to get a discount for you guys that use that link to get this meter, or one of the other ones in the line, okay? There's like 4 of them. There's 2 of them with the bandwidth of 40 megahertz and 2 of them with 70. This one's a 70, also a generator, and one of the 40s has a generator. So yeah, I'll give you those part numbers later, and let's come over here and take a look at this thing. Oh, and they did provide this for free, Banggood. They asked me when I signed up, you know, what would I like to look at. I picked this guy, so let's take a look at it, okay? Okay, so this is how it comes. It's got a little handle here, nice. It's got a dual zipper, which I like that too, little rubberized grip. So it's a nice zipper. And let's just open this. Whoa, let's open this up. Okay, this is a certificate there, quality inspection, I'm sure. This is the scope probe. You know, that's one thing. There should be 2 scope probes, I believe. We'll dig into that in a moment. The certificate here, quality calibration or quality control, I suppose. This little plastic thing. Now I've had this out, and I actually took off the plastic protector as I was. It's got a couple silicone bags in here that I thought that was a good touch. Now what it comes here is some charger. It comes with a 2 amp 5 volt charger, USB to USB-C. So, and it has the Euro type connector to the US adapter here. So test leads. Now I'll tell you what, I thought these were going to be silicone. I pulled them out, was all excited. They're very flexible PVC. Nice tension relief on both ends. Nice grippy things here. They seem good. We'll test them out. There's a USB-C. Now you notice that's kind of long. That's because the port is kind of deep inside the meter, so you have to kind of reach in. So yeah, they gave you an extended thing to make it easy. So there's that. And they call it an intelligent charger because it can do the quick charge. I think it takes 2 hours on the total discharge with the 2 amp charger. But also if you charge it with the normal, you know, USB-C charger, lower current, it can do that too. I think that's why they call it smart charger. And then it comes with 2 of these BNC to alligator type connectors. They should have sent one of those for the generator and 2 scope probes, right? Okay, let's take the scope probe out. First of all, the little book. I think it might be getting some glare there. 80 meg, there's different probes, and this one comes with the 80 meg. And the little bag of color dills and the screwdriver and the little plastic tips for when you're probing surface mount stuff to protect the pins or just to keep you from shorting things. And it's nice. This looks, you know, when I saw this, I thought it was my Siglant probe because it looks almost just like it. I think it must be made by the same people. It's 80 megahertz. It came with the yellow one on it, and yep, looks just like my Siglant probe. I mean, very much like it. Times 10 times 1 probe, very nice. The one difference is this, and it's made this way so that you can hold back here and plug into your scope because, you know, they're kind of deep, and you see what I mean? They're kind of deep down in here, so you can hold it back here. And yeah, anyway, it would have been nice to get 2 scope probes. But the one thing I want to say about this case, see how rigid it is? So I call it these soft, rigid cases. It's a nice case, and it has this bag here so you can put all your stuff in it. So, and also one tip, when you store these, just put it face down, so that way all this stuff doesn't scratch or rub on your display. Safe way to store it. Okay? Alright, I just ran calibration, went to the menu here, and it's on page 4 of 5, and it's calibrate. And when I did that, I kind of walked away after about 10 minutes. It was taking a long time. So it did finally come up with the window saying calibration complete, just hit any button. So when you do it, it will take a while. Let me take you through the menu button, okay? I let it warm up for a good half hour before I did that. Okay, you should wait a good 20 minutes, I think. I'm going to start from page 1, okay? Okay, page 1, you got English or Chinese, I think that is. You got sound on or off. I'm going to leave it on just so we can hear when the sound, just for the video. And then backlight, I cranked it up to 10. It goes down to 1. And it defaults at 6. And I'd say 6, 7, 8, 9, 10. They're all pretty good. So there's 7. I'm not sure what it looks like in the camera, but just looking here on the bench looks good. I have a lot of lights going on, so that could throw things off for the camera. Page 2, there's a backlight, starts with 30 seconds, 60, 90, 120, and infinite. So I'll leave that for this thing, for this video. Now the reference, once you've got a waveform, you want to save it so you can compare it, then just hit reference and it'll save that. And save is something different. You can save up to 6 locations. So you can save, up to 6 different waveforms, whatever. You got 6 locations to save, okay? And then you got your recall, okay? So no data because I haven't saved anything. So let's go back. And then so let's go to page 3. You got your cursors. You turn them on right here, off or on, volts or time. Channel 1 or channel 2, you can attach cursors to whichever channel, okay? And then cursor 1 would be, it shows a question mark because I don't have it on, but you move it around, it would show where it's sitting. Same for cursor 2. And then the increment is like the difference between the two. We'll look at that later. Enable, off, on. So it's let's just, okay, we're back to where we began. Let's go back. So measure. What that does when you turn it on, it turns on this box. I think I'll just leave it on for now. But it shows channel 1, channel 2, max, min, and frequency for each. Okay, and then system information. Okay, there's the model number, software number, PCB number, and FPGA version 07 it looks like. Okay, then page 4 has shut down again. It's 5 minutes, 10, 20, 30, or infinite, which I'm going to leave it there for this video. Calibration, when you hit that, it'll take some time to do. I'm guessing it's over 15 minutes because I think I actually waited 15 minutes. Okay, default. So it'll take it back to default settings. And when you don't hit the menu, it'll time out on you. So, okay, let's look at page 5. Boot logo. You can turn it on or off. Maybe it boots up faster if you turn it off, but it seems to boot up pretty fast. I'm going to leave it on. Alright, so that's the menu. Okay, now what we're going to do is we're going to go to the generator. Okay, I've got the scope channel 1 generator up here. And by the way, you disconnect those things when you do the calibration. Make sure you do that. And do the calibration whenever the temperature in your lab has changed, or maybe periodically, a couple times a year, I don't know, every so often. We're at square wave right now. When you're a generator, you can turn it on and off the generator right here, okay? So when I turn it on, it was kind of funny, I had to turn it off and cycle it. So now, see the generator here, let's go to the scope, and there's the scope. Now just this one time I'm going, I've got, you know what? I haven't really shown you the things because right now I've got channel 2 and channel 1. Here, let's go to channel, and it shows channel 2 right now on. Let's turn that off. Coupling, you have DC, AC, ground. Okay, AC, DC, ground. I'll put that back to AC. And then page 2, you got your 10x, 100x, 1000x, and 1x. So I'll put on 10x. You got a bandwidth limit. I'm not sure what frequency that limits it, but we'll look at that later. Invert, on, off. Okay, let's go back to channel. Whoops, let's go to page 1. And then right here, channel, let's go to channel 1. It's enabled, it's DC coupled. Yeah, we could put it on AC, whatever. And then, let's see. Okay, bandwidth is off, 10x, and invert. Okay, so it's set up the way we want. Now what I want to do is, we can see channel 2 has turned off the green waveform, but it still shows it up here as question marks. That's too bad it doesn't get rid of that. I understand that's something they ought to update in their firmware. But, okay, what I'm going to do this time is set auto. When I hit this auto, it takes a little bit of time for this guy to set up the auto. So if I hit auto on the mix sig, it sets it up almost the same, but mix sig's much faster, right? Much bigger, all that stuff, more expensive. So, but you know what? The waveform looks good. Now what I want to do is just take you through the generator waveforms. Let's go to, okay, there's ramp. And I'll just show you it on this scope. There it is. Back to generator, sine. Okay, back to this scope. Looks the same as that one. Trapezoid. Okay, they look the same again. And okay, arbitrary, that's cool. That's that function. Whoop, let's go. Okay, yeah, they look the same. It's kind of a cool waveform. Arbitrary 2, it's the negative one. They look practically the same again. Okay, let's do. Okay, wow, that's a dampened sine wave that repeats. That's pretty cool. Whoops, let me look at this. Go. Oh, look at that. Okay, now the trigger, here's the thing. It gives us a chance to look at the trigger. Hit the trigger, and then move the trigger up so it's not triggering on every amplitude. It's only triggering on maybe the top one, like that. See, even that one's kind of not really locked in right now. But yeah, it's locked in. Okay, generator R4. Wow, that's a wild waveform. Let's take same thing. When you have different amplitudes, it's going to try to trigger different places. So, and also when you have a dead cycle in between, it makes it even trickier. Let's see if we can get the trigger up here a little higher. Okay, there it is. It's locked in. And yeah, that's kind of interesting. Okay. Back to generator to see what else we have. Oh, we're back to square wave. All right, so that's pretty cool. That's a bunch of different, waveforms. I think from the software you might be able to download some more, but we'll look at that later. Another thing is up here across the top, you see how it's showing to connect up to that port, kind of reminding you. And then it's showing this pause play button, which is this guy. So when I turn this off, see, it changes that right there, but it also turns off the signal when I turn it back on. Okay, now let's say that's on. We're back to scope, and see how it's just jumping around. Okay, let's just say I'm going to freeze it. Okay, I froze it. My trigger's way up here, that's why it was doing that. But now I froze it, right? Now if I go back to generator, the generator's still on. Okay, now if I turn off the generator, go back to scope, see, the scope was off because it's frozen, but I can turn it back on, but there's nothing. So this button only works in the mode you're in. So if I go back to generator, see, it's off. So now I can turn it back on, go back to scope, and turn it off and freeze. Or I can bring the trigger down here so it actually locks in. Here, let's go to the generator. I want to show you something else. On each one of these frequencies, there's 2 pages, and it shows the frequency here and the amplitude. And I'm not sure how high of amplitude we can go. I think 2 volts. Oh, actually, let's go higher. Oh, 2.5 volts. Okay, it's 2.5 volts peak. So 5 volts peak to peak. And we can look over at this scope. Yep, there we go. Alright, they look the same. Let's go back to generator. I want to go to page 2. There's an offset, duty cycle. So you have these setups in each one, and then on both pages they allow you to change the wave shape. So you can do that on either page. Let's change the duty cycle of this triangle wave. See if we can make it a sawtooth or something. Okay, let's see, how do we do that? Okay, we push the up arrow. Yep, there we go. Look at that. Pretty cool, huh? Now let's go to this scope. Yep, they look the same. Back to generator. Okay, now I'm wondering if I change the waveform, if it changes the duty cycle. Okay, for a sine wave, there's no duty cycle, obviously, so let's try trapezoid. And oh, look, there's maybe three pages on this. Offset. Oh, there's the rise duty, so you got the rise time, and the fall, and the high duty, like how long it's up here. So we can make that shorter if we want. Yeah, so this is pretty cool. There's a lot of functionality in this generator. Look at that. So we can make one wave kind of a triangle and then square at the bottom. So you can really play around with your trapezoidal waveforms. Now, because this is AC coupled, the waveform floated up because it's triggered in the middle of the amplitude of this one versus that one, if that makes sense. Okay, let's go back to generator, and okay, I want to go to sine wave, okay, and frequency. Now let's change the frequency. Okay, if I push the button twice, it comes up with this table, and then once you get that table, I think 25 meg is the fastest frequency. So enter, push it over. Whoops, no, it's up and over. Enter. And then over for meg, enter. Okay, did that do it? Let's go to page 2. Okay, now let's hit the auto, and I'll hit the auto on the mix sig. Yeah, it's a little jumpy, huh? Whoops, I got to go over here and hit auto. Yeah, it's a little bit of a jumpy waveform at 25 meg. Little jitter there. Yeah, and you can see it here too. Let's go to another waveform to see what our max frequency is. Trapezoid. Okay, 5 meg. So it dropped it down to 5 meg. Okay, arbitrary. Yeah, so the arbitrary, all the funny waveforms, it's 5 meg, I suppose. Okay, square wave, let's see what that is. 5 meg. Let's see if we can make it go higher. Oh yeah, you can go higher. Okay, 10 meg. Okay, I'm going to hit the auto on the mix sig. Take this to scope. Wow, why is that mix sig looking so... Oh, you know what? Sorry guys, I knocked off the scope probe on the mix sig. That was me. I knocked off the probe. Okay, they look the same now. Yeah, I'm going to get rid of this measurement window. Okay, just so we can have a clean picture and compare. So I hit return, and once I haven't played with that menu for a moment, that menu bar will drop down and we'll get the full screen back. Okay, so what I want to do is I want to see how much we can zoom in on that wave. This is what, 10 megahertz square wave. So I'm going to go to the time button, and see that depth? I can actually increase that. The deep memory to 6K, kind of defaults to 3K. I don't really see any change, but you know, we're not looking at deep memory at this point, I guess, but I just want to get more data points. And then I'm gonna, okay, yeah, there we go. I guess 5 nanoseconds is the fastest we can go with the scope, which, you know, that's pretty fast. So, okay, let me get the mix sig at the same spot. See, the mix sig is a 200 or 100 meg scope, so I can go 1 nanosecond. I can go a little bit faster, but 5 nanoseconds. Yeah, they look about the same, right? That rise time, yeah, it's you know, it's about what, 8 nanoseconds. It's almost 2 grids. So yeah, 8 to 10 nanosecond rise time. The other thing I want to show you when you go to this time thing, okay, you have this YT mode, or you go to Y roll mode, so you can slow your trigger down. You go to YX mode, so you get a YX table here. We need something plugged in channel 2 to use that. But pretty cool that you have that ability to do that. Now channel 2 is turned on because when I hit that, it turned on channel 2. So I have to come up here, I hit channel, have to come up page 1, change channel 2 and say off again. Turn that off. Alright, so I've got my Unity, which I can go up 60 meg. Let's play around with that. But the square wave only goes up to 10 meg, same as this guy, which is interesting. It looks a little bit better though. There's the waveform right there. See it on both. Same amplitude. One thing you notice, this is 4 grids up from center. So you have, 8 grids total. Over here we have 10. And across here we have 12. And over here we have 14. So just different layouts. This is more of a square window versus this guy, more rectangular. Okay, so now I've switched over to sine wave, 10 megahertz still. Let's take it up. And you can see they're both at 3 grids up, 3 volts peak. Okay, and this generator isn't really flat at these high frequencies. You can see how both scopes jumped up a little bit, about 3.5 grids. There's 4 grids. Like, yeah, just kind of pushing 4 grids right there. And now we're at 50 megahertz, and it drops back down a little bit. So it looks like they're both tracking. And now we're at 60 megahertz on my Unity. So for a 70 meg scope, right now we're doing 60 meg, and it looks like it's following the mix-sig. So looks like it's doing good. I want to show you, when you go to channel, remember on page 2 there's a bandwidth limit. Watch this limit. Look at that. So now let's drop the frequency and see what that bandwidth limit is. Okay, we're at 50, 40, 30. See how it's starting to go up? Let's see when it matches this guy. There's 20 meg. Now we're about 2.5, and we're 1, 2, 3.5 here, so we're still getting limited. Okay, there's 10 meg, and we're at 1, 2, 3, and just a little bit. And this guy's 1, 2, not quite 3. Let's go down a little bit higher, or lower, I mean. Okay, right about there, we're at 4 megahertz. Yeah, the roll-off could be at 20, and maybe we're getting some of that down to 4, but right around 4 megahertz. Let's go to time, and 6K depth again. Let's get a few more cycles on there. Yeah, it looks like they're pretty close to matching now. I'll drop it down to 1 megahertz. Yeah, so 1 megahertz. So that's nice to have a filter like that, though, to clean things up when you don't need to see the high frequency noise. Okay, guys, we're in DMM mode. We were in scope. Now we're in DMM, and it shows what ports to hook into. I hit ohms. We could do continuity or volts, so you can see this thing change to volts. Continuity, it shows continuity buzzer. Ohms, it shows ohm. Okay, so we're in ohm setting. It's a 4,000 count meter. Now I've got a 23.2K resistor right here. I don't know if you can read that. It's a 0.1% resistor, so it's pretty high tolerance. And it's in parallel with a big old decade box. So I'm going to pull the lead off of this, and we'll see how fast it goes to here. I'll just pull it out of here. That'll be the quickest way to do it. And we'll see going from 23K to high ohms. I think it's 1 mega ohm. We'll see how fast it goes, okay? Not too bad. Okay, now I'm going to plug it back in. We'll see how fast it drops down. Alright, so there you go. Now, I'll go ahead and short the other decade box and see how fast it goes from that to short. That's pretty darn fast. Okay, now open it. Yeah, not too bad. Alright, DC volts. I'm going to take it up to 40 volts and you'll see, oh yeah, you saw it just drop down. That's what a 4,000 count meter will do. And then you have to drop down a little bit to get that extra decimal spot. Then you lose the decimal spot when you hit 40. Or 4 volts for that matter. Right there. Okay? Alright, just to show you on the other end of the spectrum, let's say you're reading millivolts like we are here. 409 millivolts. And as we come up, you see the 3 decimal spots? All the way up to 4 volts. Okay, so there you go, 4,000 count meter. Alright, so I'm on page 2 where we actually have the DC millivolts setting. So now you can read millivolts that way. And I'll just take it up to 400 and you'll see it drop down. Well, actually that's the max and the millivolts. So yeah, we just dropped out. So there you go. Just want to show you the millivolt setting. Alright, we're in milliamp setting, okay? I'll just zoom in a little bit so you can watch it. Now, this port is protected with a 200 milliamp fuse, resettable fuse, okay? But that one has no fuse, so we're going to just do this. I'll take it up to 200 milliamps and you'll see what happens. Okay, it's going to heat up and turn off and open up in a minute. Oh, there it goes. So, and we drop it down, it goes back up to, well, it looks like it's, maybe it's supposed to be 200 milliamps, but man, it goes almost to 400 milliamps before that fuse protects it. Okay, we're in AC volts now, and we got volts up here, AC here, and yeah, you know, one thing if you guys notice, the display I think is very nice. Okay, let's bring up the volts. I'm just going to bring it up to max volts kind of steadily so you can kind of see. It seems like it goes a pretty decent rate, keeps up. I'll turn it up faster and see what happens, but yeah, there you go. Okay, I'm going to turn down kind of quick. Seems like it does a nice job, right? Now if I zigzag, go back and forth with it, it's kind of what the display looks like. I think it's pretty fast. It seems like it's pretty quick. Okay, we're in diode setting, and it shows the little, God, it looks like is that a diode up there? Oh yeah, it's funny, it almost looked like a capacitor to me. That's my eyes. Anyway, okay. No beep. Alright, that's too bad. I like the beep when you get a short. Okay, it's open. It should be open there. It's a Hioki diode. Now I can tell you, okay, yeah, that looks good. 0.1111. Let's see what this other side is. There's 2 diodes in this package. Yeah, slightly different, but that's a Hioki. And they're always, you know, depending on how much test current you have, you're going to get a slightly different voltage. So it's hard to compare one meter to another. Now, you know what? Here's this bridge. Okay. Let's put the negative on the plus terminal. And touch the other diodes. 0.494. 0.516. Alright. If I go here, I'll get 2 diodes. If I can hold the probe. Okay, so, and there's 2 diodes. Alright, so the max voltage is 1 volt on this, so at least that's what it's rated for. Let's verify that. Yeah, 1.57. So it's just not a high voltage to check like LEDs. A lot of people in these video reviews love to test LEDs, but these are really meant for diode testing because that's what usually fails in a circuit, not LEDs. But anyway, I mean, not that they don't fail, but yeah, this won't light up LEDs, so sorry about that, but it does do its function. It does do diode testing. Alright, let's do the capacitors. It shows a capacitor up here, we're nanofarads. So let's do this. This guy should be a 1 nanofarad. And I think this is a 2 nanofarad. And I believe this is 10. Yeah. And that's 1 mic. Okay. And I think this is a, yeah, 220. And then this guy's pretty small. Yeah, I think it's 150 picofarad, that cap. Okay, I'm going to jump over this electrolytic. That should be a 10 mic, I believe. And now this 100 mic cap, I've measured it. It's actually about 106 microfarads. And we got an OL. So I've noticed this meter is rated for 100 microfarads, and it doesn't like anything much bigger than that. Now this is 247, so this should be 94 microfarads. There we go. Wow, that takes a while. So those big caps over 10 microfarads or 100 microfarads, it takes a little while to measure those, but yeah, boy, that could fool you, because if I would have stopped at one of those previous measurements. Alright, we're back to continuity. I kind of skipped that one. It's got a pretty sick continuity. The buzzer's not very loud. It doesn't seem to be latched. Yeah, continuity is not anything to write home about. I use a little rubbing alcohol to sometimes I didn't really feel any slickness, but sometimes there's some residual stuff left, I think, from the overmold. But it might have made it slightly better, but still, it's not very loud, and it has that kind of scratchy sound. Okay, guys, I grabbed my leads off of my FLIR meter. They look a lot like these leads. Like they're almost designed after them. It looks like those are just. These have the little gold tips, and they are silicone. That's a very nice mirror, that FLIR. Yeah, so much better with these leads. So maybe, I don't know, maybe it is those leads. Maybe this end needs to go in some rubbing alcohol to clean off. Maybe it's on this end. Alright, as I might have mentioned before, it feels like it's a nice kind of a rubberized protector on this thing. It's kind of, yeah, it feels like a little boot. Yeah, there we go. So there is a little rubberized protector on this meter. It's a nice feeling. It's a fairly girthy meter. I think it's over 600 grams, and has one of those key lock guys on it. I haven't tried to use that to see what that does, but it's interesting. This thing has these little teeth. I think that's meant for you to hang it on some, on a door or something, and for that to grip into. But I thought there might be another position for this, but it doesn't seem to be. But it does have a pretty positive clicking action. Okay, let's pull out the battery. Okay guys, so it does have a nice battery compartment, nice thick plastic, thick walls, a little thick piece here that captures in there. This thing is very snug. When it comes off, there's 2 PEMs down here for your machine screws, which these screws have a Torx head, which I think might be required sometimes. Maybe it's because of the lithium batteries. Yeah, some good sized lithiums in there. 3.7 volts, 9.62 watt hours, 2600 milliamps. So that's your 18650s. And it's marked with a positive there and a minus, so it's nicely marked. And these guys are in there snug. Okay, alright, and it's nice because it looks like this compartment separated from the rest of the electronics. Okay, this rubber boot is, pretty solid. It's pretty thick, not flimsy at all. And it has some pretty nice walls that it fits down, little channels that it fits into here. So it fits in pretty snug. Doesn't come off easily, but it does expose. There's 4 more screws, and they also look like the Torx. Got this loose now. I think I can pull this off. I don't know if those screws are captured because I didn't get them out. Alright, so of course these are just plastic screws. They don't have the PEMs in this. You don't find that often. And then there's this rubberized protective door thing that kind of fit in there. The other thing I wanted to point out is this key lock does have kind of a solid thing here screwed into it. Now there's some nice ribbing going on. This structure has lots of features. This thing is super solid. So that's not bending. Alright, and there's our insides. Okay, so this guy here, that little small resistor, is probably the pickup for the 10 amp scale, and it's a very low ohm value, so hard to get a reading on that. The milliamp one is underneath this PTC, and we get, if I can hold it there, around 2.9 ohms, and this is the PTC protection for that, 1.8, and then there looks like a pickup resistor to read the value, 1.1. Okay, and this little fella here, that is another PTC, but it's kind of interesting. He's a 1K. So he starts off, you know, a lot of times PTC's positive temperature coefficient start off low values like this and then go to high values when they get hot. This guy's starting off with 1K, so he's starting off at a decent value anyway. He must be some kind of voltage protection. Now here's our relays I could hear clicking on. That looks like a capacitor. And that's what the Testo thinks it is, 2.27 nanofarad. Testo is an automatic meter, so it just automatically reads what it thinks it is. Oh, look, there's a tantalum capacitor, that little yellow guy. Tantalums are not cheap. Aluminum electrolytics are cheap, so it's nice to see they use that instead. That looks like an inductor. Another inductor. So the power supply, the charging for this is probably going through these inductors, I'm assuming. Probably this guy. This one here, there's a going to the other board. This must be the power supply made for the other board. But then over here looks like we have some inductors. Whenever I see inductors, I think power supplies. So they could be little switchers for different voltages. But wow, look at that. Nice bar graph. I noticed they had one on the, they had the one up here. They had the other one on here. So yeah, they like to, it seems like they're doing a good job on organizing things. This board looks clean. It says Rev A09, if I can read that. I'm going to bring the board up close and let you take a scan of it. Okay, there's the input channels. They have some nice covers for the input channels. I see this one's not populated on the lower frequency or the one without the generator, so I'm wondering if that's what you need to populate for the generator. I had to take off these 2 screws and I want to open it with you guys. Whoops, I was hoping I could see another board. I was hoping they're both going to come with me. Okay. There we go. You always have to be very careful with these flex cables, these ribbon cables. You know, the first impression is that it just seems like a very clean board. I like the silk screen where the screws go. I just like the attention to detail on the board. It's a 94V0 rating. That's the flame retardant rating for like UL purposes. Another barcode. They're really big on those barcodes. Version 1.0. Okay, there's these little plastic inserts. These things hold the barrels, but wow, look at the barrels. They're solid barrels, so they're tough barrels, and these things fit snugly over them. Again, silk screen. Everything's noted. Wow, I'm impressed. Another can to protect the display. So another shield, and I can see, it looks like another shield down in there. Okay, I'm going to just kind of scan a close-up for you. I mean, we have all these optocouplers for isolation. There's that little inductor I could see from the other side. That looks like a transformer from this side, like isolation transformer. And our terminals. Scroll over here. It looks like this, I guess the brains of the operation with the crystal right here. Seems like they tried to hide what that chip is. You can kind of see it through the goop. I don't know if they try to hide it or if it's just, it could just be some varnish they did for try to keep some isolation. Right, and I just took the other board off, flipped it over, and it's pretty much just display, and that's where your pad set. Pretty nicely done. Yeah, there's looks like there's plans for another chip here, maybe Bluetooth. You know what I'm wondering is if this is plans for the growth in the automotive, because there's I think there's an 82 version of this for automotive, so maybe that's for that use. And it could be the other unused port over here. Here's a charging port, but the other unused port could be used for the automotive use too, to read the computer on the car. Okay guys, so what do you think of this? So this one here, the 70 megahertz bandwidth with the generator, is the 2D72, and then there's the C models that don't have the generator, and I think there's $30 difference between the 70 meg without the generator or the 40 meg with the generator. I think those two things are priced both right around $150 US, and this is right around $180 US. But I think you might get a discount if you use my link below for Banggood. So thanks Banggood for sending this out to me. That's awesome, and thanks for the link, and I'll make sure that's down below. Okay, so there's also the 2C versions, like the 40 and the 70, and I think the 40, so the most inexpensive version, I think is like $120 for the 40 meg without the generator. Alright, well, from what I could see is the multimeter, 4000 count, nice display, seemed like it functioned well. The continuity, you know, not so hot. The diode function, the fact it didn't give the beep, and it also is limited to about, what, 1.5 volts. You know, it'll do most diodes, I think, like even silicon carbide type diodes. So it'll do a lot of different types of diodes. But optocouplers, yeah, probably do most optocouplers too. But LEDs, not so much. So that's kind of the weakness I saw in the multimeter aspect. The generator, it did pretty good. I mean, it went up to 25 meg. It goes pretty high, but at those high frequencies, you saw a lot of jitter, and the waveforms started kind of looking not so hot. But it does have a lot of different waveforms. So, yeah, I think when you're down around 1 megahertz, or, you know, under 5 megahertz at least, but and especially around 100 kilohertz, it looked good. So, yeah, that was the generator portion. The scope portion, you know, the features are somewhat limited. I kind of forgot to show the cursor measurement, but yeah, so somewhat limited on those things. But you know, here's one thing: if you want to use this, like say, as a differential probe, I mean, you know, you could almost look at it that way, right? Put one probe in there, and now you have an isolated probe. So that's another way to kind of use it, I guess. If you're testing something, you want to put this on the output of, or the input of a power supply, and use your scope for the other side, you know, your other bench scope, then you can have an actual readout versus a multimeter. And you know, when you compare the size of this to a multimeter, it's not that much different. So yeah, it kind of a double up as a really fancy multimeter, right? And at 180 bucks, you know, I don't know. I think it's a good value, especially for someone, you know, looking for portability. So I like the 18650. I like the big lithium batteries. That's a nice feature. You know, I wish more handheld devices, a lot of these multimeters, like especially the high-end ones, say 200 bucks, 150 bucks or more, they should have rechargeable batteries, right? Okay, well, the other thing I wanted to mention is this would be a really nice addition, is to use one of these CC65s. This is a nice current probe. You just plug it in to one of your scope channels and have a nice current probe for about 65 bucks. And I bought that a long time ago. And again, they provide this for free. Just want to make sure that I mention that. Oh, you know what? And the other thing I forgot to do, yeah, I forgot to show you the software. This is where you can install the software to your PC, run it off your USB, and yeah, so there's a nice big screen if you want it. But yeah, if you want a bigger screen, you can, if you're at a bench, let's say your portability, but then when you come to your bench, you want a bigger screen, you can have like a little monitor or something. But this guy puts, you know, so if you run it off a PC, a little laptop or something, it does have a nice software utility that comes with it that you can download for free. So yeah, forgot to mention that too. All right, guys. Hey, thanks for watching, and we'll see you next time.